So we're going to talk about finding domain. We're going to just look at a couple of different things that you can come across as you're working. There's a few other functions that later on we'll talk about that have domain restrictions, but we're just going to talk about the two ones that are most common right now. But there's other ones that you actually already know, like exponential functions, log functions. There's all kinds of different ones that you know, and maybe we'll do some of those in the next video. But this is for finding the ones that you're particularly going to be doing right now. So it's none of the strange functions or the ones that you learn a little bit later on. These are just some of the basic ones that you know right away. Okay. So this is how I think of domain. So domain is a set of all the values that you're allowed to use as the input of a function. So in other words, it's the numbers that if you plug them into the function, you're going to get a real number out. Okay, so what's a real number? It means that it's not an I, it's not imaginary, it's not undefined. It's basically, most functions that you actually work with all the time happen to have a domain of all real numbers. Like this one. This is what kind of function? A linear function, right? And think about what his graph would look like. It's this graph where I go 1, 2, 3, 4, 5, and then it's 1, 2, 3, 1, 1, 2, 1, 2, 3, 1, right? And this is what it looks like, right? So again, what values of x? So x happens to be my my input in this case, so my independent variable, right? And this one's my dependent or my output. And my y, we think about him. So what values of x am I allowed to use? Like what numbers of x can I put in here to get a real number? Well, a little thing, it doesn't guarantee you're going to find them all, but think about it this way. Can I put, positive numbers in there? Sure. Can I put negative numbers in there? Sure. Could I put a fraction in there? Sure. Could I put a 0 in there? Sure. And you could keep doing this and you realize there's really nothing I can't put in there. Or if you think about the picture, right? Everywhere I go here on the x, I'm going to hit this graph at some point. So every x value that I pick, because this line is going to go on forever. So the domain here would be all real numbers. Sometimes we describe it like this guy, right? So all real numbers. A lot of the functions, all the polynomials that you know, right? I can plug any number I want in there. It doesn't matter. And everybody knows that's going to look like a parabola. It's, all the x's are going to get used. So again, a lot of the functions that you work with all the time are all real numbers. But there are some that aren't. So let's take a look at one that you will be working with particularly, like this one. I should give them different names than f, since those are all f, but I already went with it. Here we go. How about this guy? Now, we were just saying that the domain means the numbers I can plug in there and get real numbers out. And so what are not real numbers? Things that are undefined or imaginary, right? And we know that imaginary numbers are negatives under a radical. So we know here that, we want x to be greater than 0 because if I put in, well, I guess equal to 0, right? I could put a 0 in there. Or I could put in a 1 or a 2 or a 1/2 or a 1/3, but I can't put in a -1. I can't put in a -2. I can't put in a -3/9, right? They have to be positive. So in this case, my domain, I can either write this way, that x has to be greater than 0. Sometimes we write it as the numbers that it can't be, but in this case, I think this is the easiest one. Or, not the easiest one, but it's easier to talk about what can be. The other way you could do it is you could say from 0 to infinity. So this little bracket means included. So that means that would be 0 included, and this would be not included. So infinity, since it's not a number, he would get a parentheses. So this would be like, if you were thinking about it on a graph, this would be a closed circle and this would be an open circle. So this is another way. This one's called interval notation. Okay, so these are a couple of ways that we can describe it. Sometimes we describe it as numbers that it can't be. So sometimes you'll see x cannot equal something. And even though we're saying what the x can't be, that's another way we sometimes describe the domain. So let's take a look at a couple of other ones. So let's say we have this guy. So we know that we don't want any negatives underneath here because that will cause a problem. So when we're looking at these functions, what should I be asking myself? Is there any situation that would cause a problem, that would cause an imaginary number? And you can see on these ones, there's no way to get imaginary numbers, because how do you get imaginary numbers? You need to have a negative under a radical. Is there any way to get undefined numbers? Usually that happens when you have a fraction, right? A zero on the bottom. So there's no way to get an undefined number. And the other way that it is in your a lot of your functions that are like definition functions, like logs and sine and those ones. Those ones are ones where, or cosine, or I guess not cosine and sine, but maybe tangent or cotangent. Sometimes those definition functions have restrictions also. But for this guy, what we're thinking about is what will make this expression inside here negative. So when I see one that is a little bit harder, I say, well, what would make it exactly 0, right? And then we say that that would be a 10. So then I think about my 10 on the number line, and I'm going to plug in a number. So I'm going to plug in a 0, which would be over here. So if I put a 0 in here, right, 0 minus 10, that equals a negative. So that's no good. So that means all the numbers over here are also no good. So these are no's. If you're not sure, you can plug in the number over here if you want to. If I plug in an 11 minus 10, I can see that that's positive. So these ones are good. So these ones are yes. These ones are numbers I can use, and these ones are not. Now the other way you could think about it, right? If you have a number line and this is 10, well, what is this a picture of? This is a picture of a line, isn't it? Which means if this is my like where I'm intercepting at 10, it's some line. This is a positive slope, which means it has to be doing something like this. Well, think about this for a second. If this is where y is equal to 10, right? And this is x is equal to 10. So this is where it's equal to 10. This is where it's going to be above 10, and this is where it's going to be below 10. And see, I need numbers above 10 to make this come out to be positive, so I can see over here that these are the ones I want. So how would we describe this domain? We would say x is greater than 10 or equal to 10, because we can have a 0 under a radical. Or we could say from 10 to infinity, if you like that better. And this, looks a little more grown up, but all right, let's do a little bit more complicated one. And then hopefully you'll feel like you kind of know what you're trying to do. Okay, so this one has two problems, right? It has a fraction and it has a radical. So we know we don't want, so we want no negs under the, so that's one problem we have to take care of, no negatives under the radical, and we want no zeros in the denominator. So we have to figure out how to make sure that we don't get any zeros and no zeros in the denominator. No negatives under the radical and no zeros in the denominator. Okay, so what am I going to do? Again, I'm going to take this little expression and I'm going to set it equal to 0, and I'm going to figure out where it's actually 0. And actually that will tell me this one, right? It'll tell me the ones that we want to kick out for that reason. So how would we solve this? Well, it's quadratic. I'm going to solve it by factoring. So we get x is equal to 0 and x minus 2 is equal to 0 using my zero product property. So this one is x is equal to 2. So I already know that part of my restriction is that x cannot equal 0 and x cannot equal 2, right? Because that would make this 0 in the bottom, because the square root of 0 is also 0. So if I had a 0 under there, that would be no good, right? Now remember, the other thing that we want to do is figure out where is it going to come out to be negative under that radical. So you know what I'm going to do? I'm going to take this information again, and I'm going to remember that that's where it's exactly 0. So on either side of these, it's either going to be bigger or smaller than 0. Does that make sense? If this is where it's exactly 0, then when I put in numbers, on this side of 0, it's either going to make this come out bigger or smaller than 0. When I put in numbers here, it's going to make it come out bigger or smaller than 0. Bigger or smaller than 0, because these are the two places it comes out to be 0. So what am I looking for? I'm looking for the places where it's bigger than 0. I want to keep those and throw away the other ones. Does that make sense? So how do I know if they're bigger or smaller than 0? Well, I pick a number and test it. So I'm going to test like a -1, because that's easy to plug in here, right? So I'm going to put in a -1 squared. minus 2 times negative 1. And really what I have to know is it going to come out positive or negative? Well, so bigger or smaller than 0, right? So this is going to be 1 plus 2. So that's a 3. It doesn't even matter that it's a 3. It just matters that it's positive. So now I know that the numbers over here are okay. I can use those numbers in there. That's fine, right? Now let's pick a number in between 0 and 2. So I'm going to pick 1, again, since it's easy to substitute in. And so I'll just use a different color so that we don't get, we can kind of see what I'm doing here. So it's going to be 1 squared minus 2 times 1. And I think you can see that this is going to be a problem because this is going to be 1 minus 2. So I don't even care what number it is. I just know that this one is going to come out negative. So this is negative. So these guys are a no. I cannot use that in this fraction. Now let's pick a number on the other side of 2. And so let's pick, what number should we pick? 3, 4, 10, whatever one's easy for you to substitute. So I'll just pick a 3 because 3 is not that bad to substitute. 3 squared minus 2 times 3. So we know this is a 9 minus 6. So that's going to come out to be positive. So that's what we want. So he's okay. All right. So here's what we have. We have these numbers here and here, not these numbers in the middle, and not 0 and not 2. Okay. So how am I going to write that? Well, I can write it in a couple of ways. I can say x has to be less than negative 1, or x has to be greater than 2, because that describes, like the solution set of this, right? These are the numbers that I want. So that describes that. And I use or because, of course, or means they don't have to be, both of them don't have to be true. Only one of them has to be true. And, of course, I can't have both of these things be true at the same time. If it was this middle piece that had been the yes, I would have used the and. Remember? Okay. Now, the other way that we could write it, we could use interval notation. We could say from negative infinity to negative 1, but this time I'm going to use a parentheses because I don't want negative 1. If I put a bracket, it would mean I want negative 1, but I don't. And then the next thing that I would say is 2 to infinity. So this would be my interval notation way of writing that. Okay? And you may see other people, sometimes they use set notation things, the set of numbers such that. You may see this. I'll do it. Sometimes you'll see this. This says x such that x is less than negative 1 or greater than 2. I don't usually tend to write it that way, but you may see it that way. This is the way I tend to write it more often, but this one is okay too, as long as you're using the correct symbols. Okay, so that's a little brief how to find the domain of some of your basic functions, and we'll do some of the fancier ones, later.